Hi students, next relations, right? We have already seen about the Cartesian product and the cross product. Now let me take it as A as a one set, that is 1, 2, 3, 4, and then B as another set, that is A, B, C, right? Here the relation means the relation is always a subset of A into B, that is Cartesian of A into B. The relation is mentioned as R, that is always subset of the Cartesian product of A into B. For this, first we have to find out what is the Cartesian product of A and B. Right? Here A is equal to the set. We know how to write the order pair. One is mapping with A and one is mapping with B, one is mapping with C. So 1 comma A, 1 comma B, and then 1 comma C. And then next one 2 comma A, 2 comma B, and then 2 comma C. And the next one 3 comma A, 3 comma B, 3 comma C. And then 4 comma A, 4 comma B, and then 4 comma C. This is the Cartesian product of A cross B, right? So now for example, the relation is given like this. The relation R is given as like this: 1 comma A, 1 comma B, 1 comma C, and then 2 comma A, 3 comma B, and then 4 comma C. Can we check this is the relation to the relation? This is relation from A to B or not? We have used already the word. The relation is always a subset of A into B. Now check these elements are appeared here means, right? Then it is called a relation. Surely we can say it is a relation. So let me take this is the father, one family, this is your family, right? Let take it as it is a relative, your relatives, whoever may be, right? Now first member is a father, second member is a mother, and then son and daughter, right? The father is go to the relative house, whole family is going there. First the father meet the auntie and speak with him, and the father speak with the uncle. Let me take it as A is auntie, B is uncle, and C is the daughter, right? And then the mother speak only with the auntie only, right? Because he saw only the auntie, so she talks. And then see the son is talk with the uncle. The son see the uncle first, so first they have talk with them. The daughter is talk with the uncle's daughter, right? So can we say it is a relation, sir? Of course it is a relation. So by the condition, the relation is a Cartesian product of A cross B. So surely all the elements are the subset of this element. So it is a relation. Suppose in case here instead of 4 comma C, C comma 4 is given. Instead of 4 comma C, C comma 4 is given means now can we say this term is a relation? No, exactly it is not a relation. Why? We know that in an ordered pair, the first set elements must be in the first and then second set element should be in the second. Then only we can say it is a Cartesian product and then it is a relation. Here the first set and second set is interchange. So surely it is not a relation. Are you understand, students? So the first set elements always in the first place, second set element should be always in the second place. But in the second term, see the term is interchangeable, so it is not a relation. So we cannot say, we can say R is not a relation to A to B, right? Now let's check the definition for this relation. Let A and B be any two non-empty set, that is the condition. If it is one of the set is empty means we cannot be able to find the Cartesian product and also we cannot be able to find the relation. So both of them must be empty set. A relation we denote as R from A to B is a subset of A into B. Satisfies some specific condition if the first set X belongs to the first element X belongs to the first set is related to the second element, that is Y belongs to B. In a graph we have written that is coordinate of X and coordinate of Y. The first set elements always belong to the first set and the second set elements always belong to the second element belong to always the second set. That is here explained through R. Then we write it as the X relation to Y if and only if X comma Y belongs to R. So this is belongs to the relation R, the ordered pair, that is belongs to the relation R. That is the explain for relation. Thank you, students. Okay, two set is given. First I draw one set like this, and then another set. Let me take it as set A and B given in the function. So set A and B both are non-empty set. Some elements may be there like this, and then A, B, C, D. So here the first set is called as domain. What we call it is a domain. The second set is co-domain. The first set is called as a domain and second set is called as a co-domain. Here the first set is mapping with the element in a co-domain, right? It is called image. The first set element mapping with the co-domain. This element is called a range. What is called? Range of the element. Range of the element, or otherwise range of the set or range of the relation, whatever maybe we can say. So the first set element is called a domain, the second set element is called a co-domain. The range is wherever the element is mapping from the domain, right? That particular element only we can say it is a range. Suppose the mapping elements is like this. Only the mapping elements 1 to A and 2 to B and 3 is mapping with C, right? Then we want to write the range of the relations, right? Range of the relation means here the range is only what are the elements mapping in a codomain, that are the ranges. The D is not mapped with any elements. So A, B, C only the range of the domain elements, right? So when they ask range means always you have to see the codomain. In codomain, which elements are mapping, that elements only the range. Now we see the example sum 1.4, right? This is a example sum 1.4. Let A is equal to, the set is given as 3, 4, 7, 8 and B is given as 1, 7, 10. Which of the following sets are relation from A to B? Which of the following are relation from A to B? The 3 Roman number is given. First solution, we know that if you want to find the relation means relation is a subset of Cartesian product of A and B, right? So we want to first find out what is A and B. So first the set A is given as 3, 4, 7, 8 is product of the B set is 1, 7, 10. Either we can use the diagram method to write the sets, or otherwise directly if you know 3 is mapping with 1, 3 is mapping with 7 and 3 is mapping with 10, right? 3, 1, 3, 7 and then 3, 10. And also the 4, 1, 4, 7, 4, 10 and then 7, 1, 7, 7, 7, 10 and then 8, 1, 8, 7 and then 8, 10. So if you know directly we can write it, or otherwise you could write the arrow diagram. It will help you easily to write the terms. 1 is mapping with 3 is mapping with 1, 3 is mapping with 7, 3 is mapping with 10 and the remaining terms also you have to write the same format, right? Now A cross B this is the form. So A cross B is the Cartesian product. We know the relation is a subset of the Cartesian product. Now I take the Roman number 1, that is R1 is given as the set 3, 7, 4, 7, 7, 10 and 8, 1. These are the relation of R1, right? Now we have to check these elements are present in the A cross B. Within the A cross B means we can say it is a relation, or otherwise it is not. Now let's check it. 3, 7 appear, 4, 7, right? Appear, 7, 10 appear, 8, 1 is also appear. So surely R1 is a relation to. So we can say R1 is a subset of A cross B. Whenever we say the relation is a subset of the Cartesian product, hence it is a relation from A to B, or we can use the symbol also, relation from A to B. Either you can write in the word or use the symbols also. Next, Roman number 2. The Roman number 2 is given as, see, 3, 1 and 4, 12. The R2 as the relation, that is given as 3, 1 and 4, 12. Now check, 3, 1 is up here, but 4, 12 is not here, right? The B set, the second set is 12. In the second set is 12. In B, there is no elements 12 is up here. So it is not a subset of R2 is not a subset of A cross B. Then it is not relation from A to B, right? Third Roman number R3 is given as 3, 7, 4, 10 and 7, 7, 7, 8 and 8, 11 and 8, 7 and then 8, 10, right? This is given. We have to prove that R3 is a relation from A to B or not. Now check, see the first set element 3, 4, 7, 7, 8, 8, 8. In that A is given, right? In the first set 3 is up here, 4, 7, 8 is up here. In the second set, see the second set 7, 10, I write here B set, the B is given as 1, 7 and 10. Now check, 7 is up here, right? 10 is up here, and then 7, 8, 11 is not here, right? So the elements, the set 8, 11, the set 8, 11 and 7, 8. 7, 8, 8 also not in the check, or not belongs to A cross B. So clearly R3 is not a subset of A cross B. Then it is not a subset means we can say then it is not a relation from A to B. Here also if you want to add in one step means we can take it as 4, 12 is not belongs to, what is the set? Not belongs to the set A cross B. Okay students, now you understand, and the elements and the A cross B உள்ள இருந்துச்சு அப்படின்னா அந்த கொடுத்திருக்கிற ரிலேஷன் R2 relation from A to B இருக்குன்னு அர்த்தம். அப்படி இல்லை அப்படின்னா it is not அப்படின்னு சொல்லிட்டு முடிச்சிடலாம். சரிங்களா? Next we see the next sum. See example sum 1.5. The arrow diagram shows a relationship between the sets P and Q. The arrow diagram shows P and Q. Write the relation in, first is a set builder form. We know how to write the set builder form. The set builder form should be written in the ordered pair such that, right? The set builder form will be used in the such that format, right? And then roster form. Roster form is nothing but a set order form. What is the domain and the range? Domain means that is the first set element. Range is what is the elements mapping with the codomain, that is the range, right? Now check the solution. What to write the set builders form? First one we have to write it in the set builder form. Let me take it as the R as the relation, right? So the set builder form, first set I take it as A and second set I take it as B, right? First set we take it as A, second set we take it as B, such that, right? How the elements are differ here? See that the elements 3, 5 minus 3 is equal to 2, same difference, right? And then 6 minus 4 is equal to 2, and then 7 minus 4 is equal 5 is equal to 2. See the common term is up here. When we separate the first term by 2, we get 3. When we separate the first set element by 2, we get 4, right? So here B elements, if we need the B elements, meet A minus 2, we get that B. Suppose A is equal to 5, 5 minus 2 is equal to 3. A is equal to 6, 6 minus 2 is equal to 4, right? Are you understand the steps? 5 minus 2 is equal to 3, 6 minus 2 is equal to 4. This is the B sets element. Here A minus 2, right? So B is equal to A minus 2 such that, and then A belongs to P and then B belongs to Q, right? This is the form of set builder form. Next we see the second Roman number. The second Roman number is actually asking in the roster form, right? Roster form, let me take it as the set, same set, right? So we take it as a R, that is roster form. 5 is mapping with 3. This roster form should be right in the set order form. 5, 3, 6, 4, 7, 5. These are the elements having mapping, right? So that is the ordered pair. Last, third Roman number, they are asking what is the domain and range. I already told you the domain is always the first set element is the domain. So 5, 6, 7, 8. Here P is the domain, right? This is codomain, right? Domain and codomain. So domain is 5, 6, 7, 8. We want to write the range also. The range is always mentioned in a set notation form. So what are the elements mapping from the first set element to the second set element, right? What are the elements mapping or image? What are the elements mapping from the domain to codomain? So 5 is mapping with 3. You want to write only the codomain's element, that is 3, 4 and 5. These are the elements mapping. So the range is 3, 4 and then 5. This is our answer. Thank you, students.